morning, second period. I'm sorry I can't be here with you today, but I have a very sick kiddo at home. So you're going to have to go ahead with lab without me. So we have, everything is kind of set up in the room today. We are going to be doing a series of chemical reactions. And all of these chemical reactions are going to be done with ionic compounds. And as you can see, some of the ionic compounds look a little wacky. Some of them actually have upwards of 3 elements on the inside of them. Well, there are some very strange types of ions called polyatomic ions. And there's actually a chart of those located inside of your packet if you wanted to kind of look at those for reference. But these polyatomic ions, for example, if you look up here, PO4 is an example of a polyatomic ion. The P and those 4 oxygens are actually covalently bonded, and all together they work as an ion, which then goes and makes an ionic bond with that sodium. So all of the reactions today you're going to see are actually one ionic compound reacting with another ionic compound. We'll talk a little bit more about that later, but for right now, the true purpose of what I need you to see is whether or not a chemical reaction has taken place. So I am kind of hoping that you remember what the 4 signs of a chemical reaction are, because this is the purpose of part 1 of your lab today. So you're going to find in the back of the room a very large white piece of paper that has this same grid printed out on it. You'll also see a stack of page protectors. You need to go and grab one of each of those for your pair today. On your desk, you will see a bin filled with little bottles of chemicals in it. Those names of those chemicals will actually match up with the formulas that you're going to see here at the top and the side of this page. So all you need to do to get started with part 1 is to put that white piece of paper down flat on your desk, and then to put the page protector on top of it. Now, believe it or not, the page protector is relatively chemical resistant. So all you're going to do is pick up the dropper bottle that corresponds with whichever row or column that you're working on. And say I grab the sodium phosphate bottle. I'm going to put a drop on top of the plastic in each one of these boxes in the grid all the way down. And then put that back inside of my bin. Repeat that same process with this KOH, right down, and so on and so forth. And then follow through right on top of that drop that you already have inside of the grid. Then I would take this COCl2 and drop a second drop right on top of that grid. Give it a moment, let it sit. You're going to want to observe the resultant drops, not only on top of that white background, but I would actually urge you to very carefully pull that white sheet of paper out from underneath the page protector and look at it against the back background. The precipitates, one of the 4 signs of a chemical reaction, are a lot easier to see against that black backdrop. So that's what you're going to end up doing for part 1. At the end of mixing all of these together, I would suggest to pop your phone out, take a picture of what you've actually done, because you're going to probably need to reference this later on. But you should see in the front of the room, on top of the bookcases, the substitute hopefully will find this for you. There should be a stack of lab papers ready for you to accept all of this data. You're going to need to translate your observations onto this page. Right at the top of this section, it actually says Part 1 Observations. So record what you're seeing in this grid. But I urge you to be a little bit more specific than, ooh, look, it turned white. Make sure that you really try and capture what you're actually seeing, because once I get these observations, I won't have your picture to reference back to. This is going to take a while. It can actually take you almost a class period to get just this part done. When you are finished, please take the plastic sheet very carefully over to the sink. All of the chemicals can just kind of spill into the sink. Wash off that page protector very, very well. Plat it dry with a paper towel. And please make sure that you recorded your observations. And at this point, I'm going to ask you to pause the video and then when you're done with this section, come back and listen to what I'm asking for part 2. So great job on part 1. Now you're ready to start part 2. So in the back of the room where you found the page protectors and the grids, you're going to see a red bin of bottles which are marked unknown number. All of the unknowns are one of the chemicals that you had tested today already. Your challenge is to try and figure out which one of the chemicals you actually have been assigned. You can react it however you want. You're going to need to make that decision. Part of your lab notebook entry is going to be at least a procedural summary of the steps that you took to make this decision. So you're probably going to want to make some notes of what you did. I would also suggest to take some pictures of what you did, because it's going to be nice to refer back to when you have to include a data table or some sort of a reference to data inside of your lab notebook. Again, the objective for part 2 is to identify which one of these chemicals which are on the screen is your unknown chemical. A couple tips, a couple tricks that I could actually tell you. Inside of the lab packet, it actually references which part of the ionic compound will be donated in the event that a new chemical is formed, that you actually see the sign of a chemical reaction. Along the top half here, all of these chemicals were actually chosen very carefully. This was not a random assignment. If these chemicals are involved in a chemical reaction, they will donate the anion, or the negative portion of themselves, into the new chemical. So for example, here again with this Na3PO4, which is called sodium phosphate. Phosphate, PO4, is actually the anion. If it's involved in a chemical reaction, it's the phosphate part that ends up in the chemical that you're seeing. The same is true of the vertical column. So if these vertical ones are involved in a chemical reaction, then it's actually going to be the cation that is involved, or the positive ion, the thing that's out in front. So in the case here with COCl2, this guy's name, I'm hoping you would recognize him as cobalt-2 chloride. It would be the cobalt-2 which is involved in the chemical reaction. Now, that is a very long explanation for something that I think is a fairly simple piece of understanding. All of the chemicals here along the top, if you mix them with each other, will not create a chemical reaction. So for example, if I mixed in Na3PO4 with KOH, you should anticipate no reaction. The same would be true if I had chosen Na2S or Na2CO3 or Ki. It doesn't matter. Any of these chemicals along this top area, if they're mixed with each other, will not create a chemical reaction. The same is true for any of these vertical ones too, with a couple of exceptions, which I'll talk to you about in just a moment. If you mix these chemicals together, almost all of them should create no chemical reaction. I would urge you to mix specifically in the known section the AgNO3 with something like an SrCl2. That should actually create a chemical reaction, one that you should be able to track. It might create a little bit of confusion in your data. But just so you know, you're going to need to be able to compare how your unknown reacts with all of these chemicals to your known set of reactions to try and figure out what you have. And in my opinion, the most important decision that you should be making is whether or not your chemical is actually one of the chemicals that was from the top part here or from the side part here. And that's a procedure in and of itself. So I have not provided for you any data table. I have not provided for you any type of organizational method. You are going to need to come up with that. So I would suggest potentially even making your own grid and putting that underneath your page protector. Use as much chemical as you want. It's all sitting there waiting for you. And play. Just play with it. I know this part of it is really confusing, but I think if you just start to just play with it, I think you might actually get the idea of what you're supposed to do for this part. So don't stop until you have a pretty good idea of what that chemical is and make notes about the process that you used to try and figure this part out. Again, at the end of this portion of the lab, go ahead and take your plastic sheet protector, go rinse that off in the sink, use lots of water, pat it dry, and you can return the plastic sheet protector and your unknown bottle to the bin in the rear of the room. That's a lot of words. So I would suggest pausing at this point, and then the only other thing I want to talk to you about is the workup in the notebook. How is this going to look in the notebook? So if you want to go ahead and pause, work on part 2. You have the entire remainder of the class period to try and figure this out, and then let's talk how this looks in the lab notebook. So let's start talking your conclusion. If you look very carefully on the inside of your lab paper, you'll actually notice that I already wrote up a little blurb about what I'm looking for in your conclusion. It's a pretty standard lab notebook entry. Please make sure that you have a good heading, a really good objective, because there's a lot going on in this particular lab. Draw me a picture of your experimental setup, at least for part 1 in this section, and then write a procedural summary for only part 1. You could, if you're very careful, cut and paste the paper out with the data table for your observations for part 1, and if you put it kind of sideways inside of your lab notebook, it should actually be able to fit cleanly inside of your lab notebook if you want to paste that down. There's also a second data table in there. I will explain to you in just a moment about how that's going to work, but you're going to need to cut and paste that immediately after that observation table. And then you can go directly into the conclusion part for part 1 right here by answering those 2 questions. Once you've finished that, then I'd like you to go into part 2. So start with your experimental setup and then go into your steps of exactly what it was that you did to try and figure out what your unknown chemical was. Include for me your data table. So, what did you do? How did you collect data? What did it look like? I don't know. It's going to be probably a little bit different for everybody. And then finally, your conclusion for this particular section. I need for you to explain to me how you actually determined what your unknown was. So just to make sure that you understand, the procedure is what you did, but the conclusion is what you understand after having done the procedure. So this could take a little bit of time, it could take a little bit of space, so I want to make sure that at the end of this, if you have downtime, you need to start working on getting this lab notebook entry into the notebook. This is going to be a pretty big one. So at least get the part 1 moving forward in a kind of a positive direction. Okay, so let's talk about that second data table for part 1. If we move forward, so here your observation data table, that's the one that you can pretty much just cut and paste directly into your lab notebook. But then if you keep going, you'll notice that there is a second data table here. And this is for your names and your chemical formulas. The first thing that I would do on this data table is any box that would indicate that no chemical reaction took place. So no one of the 4 signs of a chemical reaction took place in that box. Put a big X in that box because you're not going to have to provide for me any additional information. However, in a box that did provide a chemical reaction, you're going to need to provide for me the name and the chemical formula of the compound that formed. So just to be very, very clear about what that's going to be, remember that the chemical on the top provides the anion, that would for this Na3PO4, that would be PO4 would be in the new compound. And then for COCl2, it would be the CO. We already talked about that, the fact that he's cobalt 2+. So cobalt 2+ comes down over here. PO4, this has a 3- charge. You can look that up on your papers inside of your packet. That's going to drip down. You're going to crisscross to get your final compound formula, and although I can't show you that on this computer, it would be CO3 in parentheses, PO4, outside of the parentheses, 2. And then his name is cobalt 2 phosphate. These polyatomic ones are named almost exactly the same as the regular ionics, same rules with the Roman numerals or no Roman numerals. So good luck, and hopefully see you tomorrow.